Hi folks, today's lecture is going to be on circles, and I imagine that you all have some vision about what a circle is. If I just draw a circle, the two things that you need to know are the center and the radius. And you know that all the points on the outside of the circle are a fixed distance, which is the radius, from the center. And that's essentially the definition of a circle. Let's just jot that down. So we're talking about a point and another point. We're talking about any point on the circle and in the fixed point, the center. And what we're saying is that for each of these points on the circle, this distance is the same. And that distance, remember, is called the radius. So let's recall the distance formula, and we'll write that down and see how the definition of a circle follows from that. So this should be familiar to you. The distance between any two points P and Q given by these coordinates is going to be the square root of the difference in the x values squared plus the difference in the y values squared. And we can see that by a diagram and use the Pythagorean Theorem. So I'll show you that right now. So in this picture I've plotted point P and point Q, and D right here. This is the distance between them. Okay, so let's make a right triangle here and you'll see how things work. Okay, so now we have a right triangle, and let's think about the Pythagorean Theorem. So this distance right here is y1 minus y2, and let's see if we can do it. This distance right here is x1 minus x2. So therefore the Pythagorean Theorem tells us that d squared is equal to x1 minus x2 squared plus y1 minus y2 squared. And if we take the square root of both sides, we get the formula right here. And in some ways, it's actually better to write this in this form. And now we'll see how we use the distance formula to get the formula or the equation of a circle. So if you recall the definition of a circle, let's call the center of the circle h comma k, and let's call that fixed distance, which is the radius, r. So the circle is the set of all points xy, which are a fixed distance, r, from the center. So the distance from xy to hk is given by x minus h squared plus y minus k squared, square root, and that is equal to that fixed distance, which is r. And generally we write this by squaring both sides, and so here is the what we call the graphing form of a circle. And it's simply going to be x minus h squared plus y minus k squared equals r squared. And that's a very, very important form. And when we have a circle written in this form, we know what the center is, and we know what the radius is. Alright, so let's look at some examples now. So think about this equation. This fits directly into the graphing form for a circle. And so what we know is that the center is going to be 2, 5, and the radius, remember, this is r squared, so the radius is equal to 5. And we can make a simple graph of that. And I think I have a graph that I can show you. So there's the graph. Notice that the center is at 2, 5, right about here, and the radius in each case is 5. So there's your graph. Okay, let's look at one more. Okay, so in this case, the center is going to be minus 3, 1, and the radius is the square root of 12, which is 2 times the square root of 3. So let's bring in a graph of that, just so you can see what it looks like. And so if you examine this graph, you should see that the center is indeed at minus 3, 1, and telling that the radius is the square root of 12, well, that's somewhere between 3 and 4, and you should be able to understand why that's true. Okay, so let's move along and talk about how we can put the equation of a circle into graphing form if it's not already there. So this is what the standard form of a circle looks like. And when it's written in this form, we really don't know much of anything. We don't know what the center is, and we don't know what the radius is. So we have to put it back into graphing form. And in order to do that, do you remember? We've got to use the skill known as completing the square. So let me remind you of how that works. So here's an example of an equation of a circle that's written in standard form. And what we want to do is complete the square. So I'm going to rewrite this and move some things around, and hopefully you'll see the technique that we're using. So this is sort of a template of what we need to fill in. And I've written the x squared and the minus 6x next to each other. And here I need to complete the square. Same thing with the y squared and the 8y. I have to complete the square. I brought this plus 4 over to that side, and whatever this is the same as this, and whatever this is the same as this, to keep it balanced. So, do you remember how to complete the square? We take half of minus 6 and square it. So that's going to be a 9. And then we take half of 8 and square it, and that's going to be 16. And then I balance by putting a 9 and a 16 here. And so now I can write this as x minus 3 squared plus y plus 4 squared equals 21. Alright, so there it is now in graphing form. And what I know is that the center is 3 minus 4, and the radius is the square root of 21. So that good old skill of completing the square comes back. Let's practice with one more. Okay, so here's a little example for you to practice with. So what I'd like you to try to do is take this equation of a circle in standard form, rewrite it in graphing form by completing the square, and once you've done that, state the center and the radius. Okay, so when you get ready, press pause, see if you can do this on a piece of paper, and then I'll include the solution below. Good luck. Okay, did you get this far? This is just kind of setting it up. If you haven't, then come to this step and see if you can finish it, and press pause again. Okay, here's the next intermediate step, and hopefully you're there, and now I'll finish it up. So that's what it is when we write it as perfect squares, and so therefore the center of this circle is at minus 1, 6, and the radius is 5. Alright, so there you go. Now you know everything you need to know about circles.